Hello, I'm Zibo, and I'm here to introduce my final project for computational photography at CMU. In this project, I focus on integrating HDR support into the infrastructure of 3D Gaussian splatting. This integration is a solid step towards enhancing the realism and dynamic range in 3D scene reconstruction. Let's explore on how this project works and how it can contribute to the field. 3D Gaussian splatting has been a groundbreaking method in novel view synthesis, introduced recently in 2023. This method uses anisotropy 3D Gaussians as a high-quality, unstructured representation of radiance fields. Its optimization techniques and GPU-accelerated rendering have set new benchmarks in real-time rendering. However, there is a crucial limitation of the pipeline, that is, its lack of HDR support. This shortcoming becomes increasingly apparent in an era where personal devices can capture and display HDR content. It would be exciting for 3D Gaussian-related applications to have the capability of taking HDR contents as input and generating reconstructed scene images also in HDR to increase visual fidelity. With this motivation, I started to figure on how to make it work. I noticed that 3D Gaussian splatting is using structure from motion information generated from CoMap along with the undistorted images as its actual input. CoMap is an open-source software that provides general-purpose structure from motion and multi-view stereo pipeline. Structure from motion is the process of reconstructing 3D architectures from its projections into a series of images. CoMap currently only supported SDR content as input and output, such as JPEG. So my work first is to bring HDR support in CoMap. The first thing to decide for the whole pipeline is what format do I need to support for HDR input and output. After investigation, I found that EXR format is a good option. It is an open industrial standard for HDR content supported by FreeImage and many other tools as well, so it's easy to debug, visualize, and convert. Now it's time for actual implementation. CoMap has a wrapper class named bitmap to handle all image-related functions using FreeImage, so bitmap is our main target. Essentially, there are three parts that we need to take care of in this bitmap, that is load, edit, and save. For the load part, I need the support for both loaded image into RGBF container or as grayscale. For simplicity and better compatibility, I use the tone mapping algorithm to convert HDR into SDR data, and then use the same grayscale algorithm as to SDR images. After extracting structure from motion data, the other part 3D Gaussian requires is the undistorted images. To generate such images, we need the support to edit pixel data directly. Here, I wrote a setPixel HDR function specifically for HDR data, since the data layout is very different for HDR and SDR data. Now that I need to save the undistorted images as new files, I need the support save HDR images. I use a function from FreeImage to get the format of the input image and keep the same extension and metadata as output. It worked as I see the output of my text images to be near lossless compared to input. To verify my work, I captured a dataset using an iPhone camera. Here's a video showing the comparison of the input and output images from the pipeline. As you can see, the histogram remains its shape, while the image undistortion process is adjusting the image output slightly to fit the assumption of the pinhole camera model. In this final project, my contribution is to support EXR format in CoMap, the image processing tool for 3D Gaussian splatting, which can help improve the quality and realism of the generated images. For the near future, I plan to initialize that pull request to the original repository and continue on HDR support for 3D Gaussian splatting pipeline. Here are my references. Thank you for watching.